All right. Tonight we are going to be discussing the fourth and fifth chapters, really the fourth chapter. I mean, the fifth chapter is kind of a short one of the Refactoring second edition by Martin Fowler. I'm joined by the usual suspects tonight, so that's good. Should be a good discussion. I really like this chapter. I hope everyone else did. So who wants to kick it off with a controversial statement? Or a takeaway or something to that effect?
Tests are terrible. No one should write them.
Okay.
If you're writing tests to refactor your application, stop immediately. You should just change everything without consideration whatsoever. Is that controversial enough?
Oh, I think that sums up the chapter great. So we're all done here. All right, let's take off.
Yeah, Jeremy, I'll now accept counterpoints.
You're going to say, Jeremy, you're saying that 10x developers don't write tests. Is that what it is?
Yeah, exactly. Write 10 times fewer tests.
Yeah. Yeah. No, I mean, I really liked that, I like that take. But I do think that it was great that this chapter is in here, just because I do feel that I find myself reaching for like, hey, let's go write tests as like an exploration. Like, let's just get in and so like using it as a way to say, well, like besides the whole academic debate of if you're changing code without tests, are you actually refactoring or you're just, cowboying it up? But beside that, I do find that it is very helpful to even understand what a system is doing by just writing an explorative test, whatever, as a way to get in there. And I think that's what the theme that I took from this chapter was, hey, as the first step in the entire process, before you've recognized that you need to make some refactorings. If you don't have a test in there to show you even that you're correct or that you're thinking about it the right way, or that you even understand what you're seeing, you should probably write some way to reproduce that. And a test seems to be like a standard way these days to do that.
Working effectively with legacy code, where he described it as cover and verify or edit and pray.
Yeah.
So I mean, to your point, I think, yeah, I like that description, but it definitely supports your point.
If we all agree about the chapter, this is not going to be a fun discussion, right?
The testing part was, I mean, I completely agree. I mean, you're preaching to the choir as far as the value of the test. One of the things I really liked in the discussion was his focus on risk rather than coverage for its own end. Mm-hmm. And, I mean, we might argue that code coverage is one of our only ways of measuring test quality, but it's a very imperfect tool. So I love this emphasis on cover risky areas, and you get good coverage comes as a side effect, rather than focusing on 100% coverage for its own end. That was the implication I took away. He didn't state it in those terms, but I kind of took that implication from reading that section.
I do agree, and the coverage thing is interesting because the easiest way to game a coverage, like a system where it's you're trying to get high coverage, is just to test like high level, just kind of write something that touches a bunch of stuff, because then that code all gets executed and you can fool tools that are looking for stuff like that pretty easily. So like, yeah, I totally agree. And I wrote down that the kind of the thoughts that he had around his style of looking for things, and like how he goes through and looks at what the class should do, and then the conditions that might cause it to fail. And like, that's where he focuses his test versus something like another strategy, which is just look at what are all the public methods and test those. And his, his point there was, public methods a lot of times are, if you have like a bunch of getters and setters and stuff like that, that are doing almost nothing, that there's zero risk for the most part in that kind of code. And I agree with that most of the time. Sometimes, depending on what you're writing, I think that there is value in kind of approaching it from what is the the expected usage patterns of my code, or what are the, like, what do I expect a caller to be doing with this thing that I'm looking at? And then how do I write a test that it executes that behavior? And that kind of ferrets out a lot of the weird bugs where you're expecting, like, you end up with things where you expect things to be set before something else is called. And like, you don't find that if you're only testing what you think is risky. Like if you're not paying attention, like there's a lot of sneaky bugs that will come up with, order of operations. I found that to be true. And I think it depends on what you're working on, whether that's a true statement or not. But I do agree with him in principle that like the goal of the test, or the goal of writing the tests from which tests you're committing, and I'll touch on that later, but like which tests are actually going to stay with your project and in your commits should be geared towards how do you find regressions, or how do you prevent risky areas that are important. So like that's where you talked about the whole, like, you should be testing business logic, not testing getters and setters, or like small manipulations that don't really matter in the grand scheme of things.
I think that makes sense, and not like not really bothering to test code that doesn't change. If it's not manipulating anything in some fashion, there's no value in testing it, because you can relatively safely assume that it's not going to have any side effects.
Yeah, I think so.
It's interesting though, because he kind of went against himself a little bit when he saw that one of his setters had a lot of business logic. He's like, oh, this has a lot of stuff, so I'm going to test this. So it's not a simple rule to follow either. And I thought about it actually from a point of, if you're using someone else's API, someone else's code, would you test all the getters and setters? Do you know how they're implemented necessarily? Maybe not. So as a developer writing it yourself, sure, you have that insight, but maybe if you're using someone else's library and you really need this thing to work, maybe you should test it, even if it seems trivial.
So that's actually a really good point, and I'm glad you brought that up, because I think the logic there kind of presumes that you know how something is implemented, or that you should know ahead of time when you're writing a test. And so it's like, it's the classic, are you writing a test to verify behavior from the outside, or are you writing a test that verifies implementation from the inside? Like, which direction are you actually writing tests? And in this case, like from this lens of I'm trying to refactor code, I think there's some in both camps. Like you should write some stuff. So in that example where he had a setter that had a bunch of logic inside and he knew he needed to break it up, I think it's totally okay to write probably one or two or several tests that are testing like the pieces in there that you suspect you'll probably refactor, or suspect need to be moved, or done something with. So I think that's an okay time to do that inside out, kind of like, I understand the implementation, so I'm writing a test for the implementation to ensure that eventually with wherever I end up placing this, I have some code that shows that logic and keeps me consistent with it. However, I think that's like the big point in the chapter where he was talking about like some of the tests won't survive. Like some of the tests, you'll write them and then you'll throw them away because they're only there to verify a piece of behavior that you're refactoring somewhere. And so like once you've done that refactoring, it's no longer a valid test. Like you would no longer want to test that setter is doing those 15 things. You don't want to test that whatever you wrote now does that. And hopefully in the process, you've written a test before you did that refactoring on wherever you're putting it. That's, I think, the goal. But so yeah, very good point.
And I think that's a completely valid way of looking at the code as well, is that he knows this code and he knows how it's going to test. But I think it also points to me to one of the biggest weaknesses in this chapter, is that the example code was too perfectly testable. Like in the real world, code which isn't, I don't often see code which isn't unit tested, which you can just unit test like that. So for me, the example here, while it showed how you would add unit tests to code once you got it to the state where it could be unit tested, it missed entirely the usual reality, which is you come across a giant lump of code which is fundamentally not unit testable or very hard to unit test. So how do you get it from that point to where you have enough of a test harness in place where you can begin to refactor? And of course, working with legacy, effective legacy code covers a lot of that, and it's a totally different book. But I feel that was the weakest part of this chapter.
Right. It definitely felt like he was just trying to graze the very surface of it and say, if you're interested in more, you should probably read a different book. That's kind of the impression I got.
Yeah.
Does the previous chapter kind of build into it though by talking about code smells and sort of what you should look for? Like clearly, like it's a clear-cut example because it needs to be for the purpose of showing the value of testing, but for the purposes of understanding, like kind of like just driving home the point that, hey, you're actually like, this is a pretty small example, but you're going to run into larger examples, and that's where you're going to need to start looking for these different code smells. And then leading into what's coming too.
Yeah.
I felt like I wasn't distracted personally by like sort of how cleanly they were able to like move around, because I think it's establishing I don't know, it's just establishing like kind of like this is the idea behind it. But yeah, your mileage may vary what you're actually going to encounter in the wild.
And I completely agree. And I to that point, I would have loved him to have some discussion about that, because I could imagine someone very inexperienced, very green, maybe a junior developer reading this and being like, oh, this is fantastic, this is the way. And then they open the project they're working and be like, well, hang on, this is impossible. So some squaring of that circle would have been nice in mind, even if it was just a paragraph discussing, you don't often find code like this in the wild. However, the other thing that, maybe this is related to it, but his approach of the testing was very much, I know how this code works, therefore I'm going to add these tests that exercise it. But there is another approach which you can actually get unit type tests in place without understanding a thing about how the code works. There's a group of libraries by Lowell and Falco called approval tests. So it's in PHP and Java and C# and stuff like that. But the idea being, if you can find a pinch point, as Michael Feathers describes it, a point at which a single method call drives a lot of the code, and as long as you get a return value, you can just store that and verify it like a gold master or a snapshot test or approval test. It's all the same thing. So, this example that he uses was very much, I understand this code, I can test these methods independently, I'll add a unit test, which is probably still the best thing in my mind. But frequently when you can't do that, maybe an approval test is a better case to get the coverage that you need.
Right. Yeah, I think there was something you've all discussed like in the past few weeks, how it's like he's making this assumption that he's the only one that's working with this code base, and he's kind of going into it with like, I have this foreknowledge of this code, and for some reason, even though I have this foreknowledge, this doesn't have tests in it. I must have really just been really ignorant about it at some point in the past when I wrote this, and now I'm going to add it. But there is that kind of opposite side where you don't know anything about it, and you're encountering this set of code fresh, and hey, oh my gosh, it doesn't have any tests, and I need to change this because I need to add a feature or fix a bug or something like that. How do I get started? And I think for me, kind of going through this again, like, because I read the old version a little bit and like going through this process again is kind of giving me fresh eyes of like, oh yeah, I can just look at a brand new method and kind of like, can I figure out what's going on here? And if I can figure out what's going on here, can I write some tests for how I think it's supposed to work, so that I know at least I have a baseline for if I break something when I'm trying to refactor it as I'm working through, I have that expectation. And I think that's I think it raised a good point, because it's just something he's familiar with, but it does speak to like, if you don't know something, it kind of gives you, I like the way that he's building the story here, because it's kind of, here's some code smells, here's this idea of testing, and now we're going to actually get into like all the different types of refactorings based on that.
I liked how he also like distinguished between, I'm writing tests to this so I can refactor, versus like traditional test coverage of, I'm writing tests for something I just wrote, where he had those two different types where he may not write a certain test if he's just trying to get to a point where he can refactor, versus coming back to that later and potentially writing that test at a different time.
Antonio, were you going to say something a moment ago? I felt like maybe one of us stepped on it.
No, I'm fine. Sorry.
Oh, okay.
One of the things I found interesting in kind of the talk was, when do you stop? Like the whole question of how many tests are enough, or how many, like what's the rule? Like how do you determine that? And I think so like I call it like the older stuff, or the older thought around a lot of this is, treat your tests as like the safety net, or like something that's like, oh, this is gonna, the whole risk analysis, and this is gonna prevent future regressions, and this is gonna catch all the bugs, and there's no chance that anyone can ever break my code once I've written, 10 unit tests. And like I think that's, obviously that's, we've learned, I hope by this point, that that's not really the case. So I think like the question of how do you figure out when you've written enough tests to even do the refactoring? I think that's an interesting one to explore. And like, I don't know the right answer to that, but I think kind of to the point earlier about, the previous chapter leading into this one, like an interesting exercise, I think, would be to look at when you identify a smell, like what test do you write? Or what types of tests, what areas do you put them? Do you write to, either confirm your suspicion that that's the code smell that you're seeing or smelling? I guess not seeing. Do you see your smells? I guess if you're on LSD, maybe. But so, is this correct? Like, was I accurate? And then do I know the correct treatment for that? And then use the test as a way to say, identify this smell. So like, well, I guess what I'm saying is I would love to be able to like go historically and see like, hey, I saw this, I wrote this test, and then did it actually help? And then is that the right playbook for this? Like, what is the correct, or not correct, but like, what is a good process to get from code smell to test to refactoring in that kind of loop that we're all accustomed to? I don't know what my point is there, but I think it would be a cool project to explore. Like, how do you apply testing in cases where you identify like a potential smell and then get to a point where you can spray air freshener over it?
Or is it possible even?
True.
Because is a smell associated with a test, or is because you're testing some kind of return, right? Or some sort of output or something. And so the refactor is going to lead into it still working the way that it did, presumably.
In theory, yeah, but I
like
think
it should, right?
I think you could. So like, if you could associate a smell to a set of refactorings, in theory, you should be able to, in the process between those two, you should be able to write some sort of test that verifies, or that, pins that behavior down, so that you're like, I know that this is what's happening. I know that this is probably what I'm going to do. Here's proof that I didn't destroy everything when I did it.
Mm-hmm.
Sounds like a good project for Jeremy to undertake.
Which
And
Jeremy are you talking about now?
And I assume by that you mean Jeremy Cook, of course.
No, I think you Jeremy Ward, definitely. All the Jeremys. No, it's interesting because when you, I had much the Jeremy's reaction. I was thinking like, the code smells seem to me to be another level. And then I was thinking, well, hang on, maybe a bunch of the code smells are kind of class level or method level. So for those ones in particular, maybe there is a link. I think I would struggle between, I can't think of a specific example, but I would struggle maybe with some of the other ones, like the lower, I'm going to call them lower level ones. But, but as long as your test was, as Jeremy said, it's testing behavior, it's testing a return value rather than testing the implementation. But it will be an interesting one to track down.
Yeah, it's entirely possible that there is no link, right? Like, I'm just saying, like, I think it would be cool to see, like, as you develop your own like internal, like he referenced like, the style that I follow, or the way that I typically approach this is this way. Like, I'm curious if there is a way to, even at an individual level, like say, hey, when I see this, I typically am reaching for this. And so like, this is how I this is how I know to test it. And like, if there is even a link there, like, I think it would be an interesting thing to explore.
I look forward to your series of blog posts and conference talks on this topic.
Yeah. All right. Cool. Well, my Sunday nights are booked, so I don't know if I can, get right on that.
I thought there was one contradiction between last week and this week, and I wondered if anyone else thought the same or you had any insights on this. But towards the end of last week, he was talking about using automated tools to refactor, and how if you have great tools, maybe you don't even need tests sometimes to do refactoring. And then he opens up very much this week by saying you always need tests to do refactoring safely. And I mean, I have my own ideas on that topic, but what did anyone else think? Did anyone else pick up that kind of disparity?
I'm trying to remember if he said that. I wonder if that was perhaps misinterpreted.
Could be.
Because I think he was previously like expressing that there's a lot of great tools now, but there's still like this loop, this process of like do this and run tests. And so I think tests from the beginning have been a very like foundation of this book, that there's that loop. So I'd be curious if you can find where it was from last week, where that might have been.
Yeah, actually it was 2 weeks ago. It wasn't last week. I just flipped back to it, and he talks about, maybe I misread it in the sense he says the tool completes the refactoring for me, and I'm usually sufficiently confident in its work that I don't bother running the test suite. That still implies he has the test, of course.
And I think that was based on like a limited set of types of refactorings, right? Like I think maybe like, we haven't explored it at them yet, but if you looked ahead, of course, like extract like function or like the first couple that in there, I bet are ones that are common in PHP Storm, at least, which is the tool I work in, where, yeah, you can feel pretty confident that, oh, hey, this is still working the way that it is. I think that's probably the point that he was trying to drive home, that he didn't feel like he needed a test for like some of those things immediately, but of course, I think you might still want them. I don't know. That's a good point. Maybe it is.
Yeah, I interpreted it more in the context of like the loop. Like previously he was really hammering home, I make the refactoring and then I immediately run the tests. And I think I interpreted it as, oh, I don't necessarily need to immediately run the tests when I've used these automated refactoring tools.
Yeah, to me, it seems like it's the ultimate safeguard. Okay, you have all of these tools and they work, but to be really sure that everything is still okay, we need to have this test.
I mean, my approach in this kind of stuff is, and again, coming back to the point with, if I'm looking at a piece of code that's not unit tested, it's not unit testable, I'm gonna lean on my tools to hopefully get me to the point of doing just enough refactoring to get me to the point where I can add tests. And then at that point, I'm going to go to town. But it's, it's interesting because, I mean, I got the impression from reading this before, and I'm just skimming this again. I can't find the exact
I agree
thing.
with you, Jeremy, that he kind of left that impression that, okay, you have these tools, they're going to work.
Yeah.
But it's like with Tesla, right? There is this self-driving, but you still need to be alert, supposedly.
Mm-hmm. Yeah.
I think it kind of implies that, so there's a trust there that you identified the correct refactoring, and that you trust that your tests that are already there are covering you enough that what you're doing is not like, it's probably like I think he's more saying like through experience, he knows that once he's looked at like the test level, or, he's satisfied that it's covering him well enough, that there's a subset of refactorings that, are provided by automated tools that he knows in doing them, he's not afraid, or he's confident that he isn't going to break things that he already understands, like has a good understanding of the level of the testing that's in his code base. That's probably what he was getting at there. I don't know, like I don't think personally I would say if I'm leaning on tests to help prove that my changes are not breaking things, I would probably say that it's a good idea to run them every time, even if you think you're safe, because inevitably when you think what you did has no effect, it always has an effect. Like that's just the rule.
That's when it gets you, when you let your guard down.
Yeah. When you're like, no, like PHP Storm would, like, or IntelliJ or whatever would never let me down. Like it's never formatted my files incorrectly or whatever. It always does the right thing according to the configuration that I've given it. Yeah, so it's like, yeah, I don't know. I think the larger point in like the whole, you need to have tests to be able to refactor effectively is that, it's any tooling isn't going to make or isn't going to replace an understanding, right? So like the tests are there to help you understand what needs to change as much as it is that you didn't break something. Like it's like and that's what that's what I love, like my exploratory, like it's all about using code that exercises the code so that you can prove that your changes didn't affect how the code gets executed or the results of that execution.
Mm-hmm. And I completely agree, but I think where I encourage people to really lean on the tools, well, I mean, two reasons, right? One is get code from a place where you can't even add a unit test to a place where you can add a unit test. Like if you're doing an extraction of a class or a method or breaking a method down or introducing static setters or any one of those other things that let you get a test harness in place, if you can leverage the tool you're doing to do all of the work for you, you're going to be in a much better place than if you manually type it yourself.
Yeah, because
the tool doesn't make mistakes in my experience. Like you can choose the wrong thing to do. Normally for me, I find, I mean, I use IntelliJ, so I mean, all the same refactorings for PHP Storm or RubyMine or whatever are all there. If the tool is telling me I can't do this, I'm probably picking the wrong thing. I normally find that if the tool does it, it does it correctly. And the other thing I would, and then I completely agree, right? I mean, I want tests. I don't want to be, doing the tightrope act without a safety net. But if I don't have a safety net, I have to somehow get to the place where I can. But even when I do have the safety net, I'm always trying to get the tool to do everything for me rather than manually typing it myself. Because again, it's quicker, and B, the tool doesn't make the mistakes that I make when I manually type it. But it's an interesting one because I mean, there's the tooling has come on, I imagine, so much in the last 20 years, and even the support in IntelliJ or PHP Storm for JavaScript projects now is incredible, right? The stuff it does for you and the insight it can give you is astonishing. And I wonder if that's even changed since the second edition of the book was written. With the correct set of inspections and the stuff you can see and the idea will fix for you in your code is incredible.
If only it could interpret requirements and turn them into code for me, that would be. That's the next level, where like you just
different jobs.
You just read the requirements, put them into like whatever IDE you have, and it just turns it into code, and you're like, yeah, that looks right, looks good, just run it. Yeah, yeah, I think so. Like that's. Oh, go ahead.
Oh no, I was just gonna say, like, I agree the tooling has definitely come a long way. It brought to mind, last week I was doing some refactoring, just some practice exercises with my team, and we were using the refactoring tools, and it made a suggestion, like we were extracting a method, and it made a suggestion, oh, looks like there's this other duplicate code over here that looks the same. Do you want me to do this too? And actually it was, no, we didn't. But so there are opportunities with these tools where they make suggestions and you could still accidentally click the wrong thing or say, yes, please do all instances, and find out that this actually wasn't exactly what you wanted. So not that I think I completely agree with you, but I think there is that level of they can get too eager as well.
I completely agree, and I find when I don't have the safety net, I'm usually extremely cautious, right? When it says, do you want me to fix all the things right now? And I'm like, no, actually, let's just do this one thing. And when I've got the test later, then I'm much more likely to say, yes, fix everything for me. And oh, by the way, it blew up. And now I'll just unwind one step and go forwards, taking much smaller steps, right?
Yeah.
That's usually the way I think I find it. Yeah, for me, it works anyway.
So trust, but verify what your tools do, right? That's, yeah. They've come a long way, though. It's a long way from find and replace variable name in all files with like with like CLI tools or something. You're like, I hope that works. I don't know. Like, project is definitely going to be project everywhere, right? So let's just change the name of this real quick. Yeah, and I think so. That kind of leads into something that I found interesting. Like he talked about how, you know, testing or you know, writing tests is an iterative activity, and how he tends to find himself spending at least as much time in his tests as in the actual production code or the main code, whatever he called it. And then he closed out the chapter with like a paragraph that said, it's possible to have too many tests. And when you find yourself working more in your tests than you're writing in your code, that's probably an indication that you may have gone overboard with the testing. And I was like, well, that's kind of interesting, because earlier you said like ideally you're iterating as much in your testing as you are in your main code. And like, you know, personally, I found that it's probably like a 2-to-1 ratio most of the time. I feel like, or like, it feels that way anyway. And I think that may be part of the whole process of, to really understand the code, you spend more time in the test, because the tests are where you figure out and test your assumptions. And like, that's when he talked about the whole, like all the boundary testing and exploring, like, well, what happens if I give it a 0? What happens if I give it a negative number? What happens if I, you know, set the demand to negative 3,000 and then, you know, whatever. So like all that testing, I think you spend, and you should spend. I think it's healthy in, especially in a new code base or in something that doesn't have tests. I think a 2-to-1, maybe even like a 3-to-1, like maybe a very high ratio of time in tests to time in changing the code is probably what you should aim for. So like, I don't think you should measure, especially not when you're introducing tests in an existing code base. I don't think you should measure on that last paragraph in this chapter that's like, you know, you've probably written, or you probably have too much testing, or you're putting too much effort in the testing if you're writing more, because you should be at that point. Like you can't get to a point where you trust the tests if you don't spend the effort to really put all of the assumptions in there and all of the stuff that's unwritten about like configuration things that happen on the fly magically in these one modules, but in unit test land, those things don't exist. Like you're not pulling all your environment variables, and they're not all there in perfect, you know, ceremony or whatever. So like, yeah, I think it was interesting to see that progression of like, you know, started off with, you can't refactor till you have tests. Don't spend too much time writing your tests. Don't write too many tests. Oh, by the way, there's such thing as writing too many tests. And it was like, well, what's the message here? Like, what if I can't? Like, what if I have to spend too much time writing tests? Like, that's, some code bases are like that. They're not all as pretty as this little producers thing that you've shown us with its 5 inputs. It would be nice to get a project like that. I could have it done in, you know, a day. Problem.
I think it's something that kind of gets glossed over a little bit with testing suite, though, is that I kind of wrote this down, which is like, when do I remove tests? You know, when have they, you know, he kind of talked about these aren't going to hang around. Some of these might not hang around, but the ones that do they ever need to go away? Like, is there ever a case where tests are still passing, but they're not really doing their job? And when do you refactor them, and when do you take them out, and how do you know when to identify them? And like you said, this isn't a test book, it is a refactoring book. And if you need to refactor tests, where's that book?
The answers to your questions, Jeremy, are the classic answers, which are yes, and it depends, right? Like, yes, there are absolutely tests that even though they are passing, they no longer serve a functional purpose. And I think that's kind of the point he's trying to get to with the whole, you know, write tests that are valuable in terms of risk prevention or risk, like the risky side. So you'd have to develop what is the level there, and looking at it like what's in this test. And it's like that's where the whole don't test simple setters, don't test things that are doing barely any work. But you'd have to look at that like on a per project and per it really depends. Like if you're like the audience of the code, if it's you can take a lot more risk. And so like if it's an internal thing, I think there's a lot more tolerance for deleting tests that do like simple things. But I wouldn't like there's not an extreme cost to test it. So like I would say like it's all the tests that we talked about being invaluable because they don't really test anything that's useful. Those run in milliseconds. Like they're tiny, so they're not preventing or like causing you any real grief. The ones that are, in terms of like you'd want to delete them because they're taking time or they've got like really complicated setup, those are the ones that you really want to keep around because they're risky. So I think yes, and it depends, right? Like that's just how it works out usually.
One of the other things I find with this, and again, this maybe comes out of the idea of approval tests and pinch points, that frequently with code that isn't unit tested, the only kind of tests I can get in place are ones where I've identified a pinch point, and I can drive a lot of code and verify the result that comes back to me. Usually for me, after the refactoring, I kind of have the choice, right? The test I've written to enable the refactoring to happen now becomes an integration test in a way. If it still has valuable, it's kind of an integration test. It's testing collaboration between multiple objects usually, or multiple pieces of code. If the structure has changed so much that there's no single call now which does all the things, maybe that test doesn't hang around. Maybe it's not even valuable to have that as kind of like an integration test, but that's the general kind of heuristic I tend to think about in that kind of case. I don't know if that's helpful at all.
It is. I think basically you're saying like when I think there's two things there. One is when you've written a test at usually a higher level so that you can be able to pull things apart in such a way that you could write lower level like unit style tests. Now you've got coverage in that area. So is that higher level test still valuable, or are the suite of unit tests more valuable? And I mean the answer is they're both valuable, but you have to just analyze like does it make sense to keep that higher level test because it's usually much more coarse, and so it's executing one thing, it's executing 15 things, and so like the cognitive, like to understand what's broken in that test is going to be 15 things. So it boils down to that one change affects one thing. So like you could change 10 files and it would affect this one test. So it's probably, I would lean towards deleting that one since it's more likely to cause issues that are unforeseen or very difficult to track down. And then the other side of it is, has like what you said, like has the structure actually changed such that that test is no longer really a valid thing? Like you're no longer, that's not the expected path to execute everything anymore. Yeah.
Right.
Cool. Agree.
So in the middle of that section that you're talking about too, with like, how do I have too much tests? When do I need to do? He says an important habit to get into is to respond to a bug by first writing a test that clearly reveals the bug. And I think that's like, it's kind of too bad that it's buried in the middle of that paragraph, because that's the part that needs a quote. I feel like the whole purpose of having these tests in the first place is that so when something goes wrong, I mean, it's to like do it the way, write code that we know works and confirm that works. But also when something goes wrong, we're able to say, oh, hey, that's a case we didn't catch or we didn't think of. Now we're going to go write a test for that case and we're going to go fix that bug. And I feel like if I were Fowler, I would like hoist that up somewhere, put it up on a beacon, shout it out to the world, like this is the value of tests and this is refactoring as part of that process. That's going to like, that's going to be a point in which you're going to need to refactor because you have a bug now and you're going to have to fix it.
I completely agree with you, but I think there's another aspect to this that, and I don't think he really calls this out much in the book, is that I think I've said this before, but the tests make you fearless, right? That I know a lot of people who are terrified, who are working in code bases, who are terrified to change the code because they don't have tests, they don't have fast unit tests. But the minute you've got fast coverage and you can instantly verify whether your changes are correct or not, you can change the code in whatever way you want without any fear. I don't think he emphasized that. I might be wrong, but I don't think he emphasized that in this chapter. I don't think he emphasized that in other parts of this book. But it's kind of implied that this is, this is part of the value of having a great test suite, a great unit test suite. But I don't think it's explicitly stated.
Yeah, Jeremy, I think the closest thing he says is it should increase your confidence.
Yeah.
But he never says anything like it removes all fear.
I
Because he
all
admits,
fear,
like,
again.
even having tests, you won't find all the bugs. Like, there's no way you're gonna find. So he openly admits that. But you should do enough to increase your confidence. But yeah, it'd be nice if he could say something like, "Yeah, you should make these change fearlessly." Almost.
I mean, I'm going for a touch of hyperbole here, right? Because obviously it's not fearless. There's always a risk in every change you make in code, but it's about reducing that risk as much as you can, right? That's all we can do.
Two things. One, I've met some people who are fearless even without unit tests, and I, withhold whether that's good or bad. And then I do think he touched on that a little bit implicitly. So he didn't, like you said, he didn't explicitly say, hey, this is all about comfort and being able to change things without fear or have confidence that you're not breaking stuff. But he did talk about the like when he was talking about IDEs or tooling that really quickly shows you like the green bars, the red bars, whatever. And he was saying like on teams that he's worked on, like a common theme is get back to your last green. And I think that's like that whole process of, how does a test suite really get you into the mindset that, hey, it's okay to go through this and make changes, and then maybe they work out, maybe they don't. And it's also okay to throw away some of that effort. Is having that quick, commit loop and that whole, red, green refactoring loop and et cetera is, hey, I started this refactoring. Now everything's red. I have no idea why. Just discard it and get back to the last point that it was green. So that previous commit, just roll back and then start again or write a different test this time. So I think he touched on it a little bit in terms of how it does spark that, I would call it comfort, but that ability to say, hey, it's okay to make changes and it's okay to explore and it's okay to jump off the path a little bit and then see what happens. You always have a place you can go back to. And that's only given by having tests that are a place you can go back to, I think. But otherwise, yes, I truly agree.
Yeah, no, and you make another interesting point. Like the undo thing is so important here because I think all of us have the tendency to be, if I just change this thing, it's all going to work. Oh, it still doesn't work. If I just change this other thing, it's going to work. And then before you know it, you've gone so far down the rabbit hole that you're 30 minutes in, it still doesn't work. But you're loath to undo your changes because now you've wasted 30 minutes or 3 hours or 3 days or whatever it is, right? So this whole, as soon as it doesn't work, go back to the last passing step and start again, I think is so important as well.
Yeah, I think there's a healthy mix there, though. It's like,
yeah, of course.
Sometimes it's, a lot of times when I'm writing code, it's like the first thing I write is horrendous. It's like, I would never wish this upon anyone, but it does the job, I made all these 50 changes and it's like, now let me holistically look at this. And so like at that point, usually if I'm being a good person that day and, I'm writing tests before I write other code, which happens all the time if anyone's listening. But at that point, once I've gotten to the point where I'm like, okay, I fully understand what I should have changed now, or, I've gone through this rabbit hole of exploration and changed 17 different files. And it's like, let me take a step back. What do I actually need to change to make this happen? Like, look at it. Like, I look at it in diff tools. I figure out like, what did I change? Which files did I change and why? And then from there, what test should I write? And so that to your question earlier, Jeremy, the other Jeremy, which test do I throw away? And it's usually those ones that I wrote or changed or whatever that are no longer relevant based on my understanding right now of what I actually need to do to fix this or implement it or whatever. So like that's when I would write the final test. Like this is what I actually want to turn in. So it's kind of like the whole rough draft process they tried to teach you in school. Like I don't know if anyone else was like me and like you write your final draft and then you write your rough draft to turn in with all the mistakes. So like it's the opposite in programming for me. Is I usually actually do write the rough draft, but
No, I agree, and my point is more to the fact that when you're doing refactoring, right, if you're spending more time, usually maybe there's a time limit, maybe it's 2.5 minutes, maybe it's 5 minutes. If you're 5 minutes out and you still red, maybe that's a sign you should undo and go back to the last passing state and try again. It's not so much what you were illustrating where you have something that works but is maybe not how you would want to submit the code. But I agree with everything you said.
I think I might have, so I'm thinking about red, green and this refactor and so I had said something earlier about fixing a bug, which was kind of not true to what Fowler said in his book, which is that you're changing code for the same result, right? So so sorry, I'm gonna like try and pull a couple of threads together here. So I'm kind of thinking about this as I go. So red green is interesting because if we're talking about strictly refactoring, like you're just going through the process of trying to leave the code in a different shape than it was, but with the same effect. I wonder if we're conflating that a little bit with sort of like changing the code to like fix a bug or kind of like move it around in some way that causes the test to fail and like kind of unwind. Are we still thinking about this in terms of like, hey, you know what, I'm going to extract a variable here, or like, you know, make a new method out of some block of code and suddenly like things are turning red. That might be more of a smell that, whoa, something really went sideways.
Yeah, no, I think you're right. Because I mean, isn't the idea of refactoring is, oh look, the test still passed. Oh, still passing, still green. Oh, still green, right? I mean, it should never be broken, right? That's the ideal.
Because it's small changes, right? Little tiny incremental changes.
However,
go ahead.
I will say that, so this like brings up the thing that I was kind of chuckling about while I was reading this is, you know, a lot of times in the ideal world, yes, like you make changes, your tests still pass because the refactorings are not changing the overall behavior. In the real world, in my experience anyway, a lot of times, depending on how and when the tests were written, like that whole lens thing, like which direction were they written from, the tests will fail because they are dependent on the implementation significantly. Yep. And so then it ends up with, okay, so if you're being true to this book, like what I was chuckling about was, in theory, you really need tests to cover your tests so that you can refactor your tests while you're refactoring your code, right? Because how do you safely, like you're going in something and you made some refactoring and now you've got these red tests because they were depending on implementation. How do you prove that the changes that you're making to the test suite are actually correct versus what they were before, and that you didn't just mess up your refactoring because you trusted your tool or whatever? Like it's an interesting paradox, I think. Like you're in this state where it's like, who's watching the watcher, right? Like who's the safety net for the safety net? I don't know. Like I don't know the answer, but I think, yes, I agree that it is the theory anyway, but in practice, it's usually not the case because you end up with, especially when you get into like mocking and you're stubbing things out and you're like, depending on how all of that was implemented, if it's truly depending on interfaces only, then you're probably a lot safer than that time you're like, oh, well, actually, no, I type hinted on, you know, a concrete class here and I, you know, did this or whatever, or these method names, I'm changing them all, but I didn't know that someone dynamically mocked it over here. So now like the test fails because I changed something, but it passed the test still passes because the mock object still works the same way. So like, yes and no, right? Like it's ideally it would work, but it doesn't actually ever work for me.
Is
anyway.
this
Maybe
another
I'm just
smell? Is this another smell though? Like is the smell when you see a unit test, which is coupled to the implementation, there's a clear sign that something is very wrong.
Mm-hmm.
It almost feels like we should think of a pithy name for this one, or and suggest that it's in refactoring the 3rd edition or something like that. But like, because I mean, to me, the minute you couple the test with the implementation, you've lost the ability to change the code freely.
Mm-hmm.
You're now, I mean, there's a library in Java called Power Mockito, which allows you to mock static methods, to mock final classes, to mock new, when you're testing something that creates a new instance of something, you can mock that. It actually goes in and rewrites the Java bytecode to make all of this possible. But again, as soon as you do that stuff, you've just shot yourself in the foot.
Mm-hmm.
No, I mean, if it lets you get a test in place, then that's valid, but you should be getting away from that, to my mind, as soon as possible, because the design is not allowing you to, what am I trying to say here, to really be flexible and to allow the change to the code to be changed easily. It points to many smells.
Yeah, that's really interesting as like a possible addendum or something, because it's this idea, like what you and Jeff are both saying, is like you kind of have bad tests, right? And in order to refactor, you have to refactor the tests. But how do you know if you're also supposed to trust the tests as like trustworthy? Like, these are telling us that our code is accurate and doing what we say. If you go and change those tests before you refactor, then you're sort of like, what if you make a mistake there? And now you're kind of like dissolving that trust a little bit, because now you might have broken something in the test suite that's giving you false positives, and now you're like kind of unwinding things. It's a really interesting, that's like a whole separate hour, I think.
It's a whole nother book. I think
Yep,
it's a whole separate book. It's refactoring the tests for refactoring, right? Like, we'll have to come up with a better name, but probably write it. Yeah, it's absolutely a smell. Like, I totally agree. Like, I know that from picking up projects, and even my own stuff that I've written, it's like a lot of times you make those compromises in the process with full intention to fix it. You're like, oh, I know how to fix this, and you know how to do it today. However, next week when you're doing this again for a different place, and then the next week for a third place, and now you've got all these places, and the sneaky thing about them is they're not always, they don't always break in predictable ways. Like, when you do make the change that is going to break the actual code, a lot of times, depending on how crafty you are with mocking frameworks or anonymous classes in your tests or whatever you're using, like, depending on how crafty you are, you can set it up so that your tests always pass, regardless of how the actual implementation works. And like, that's probably the most dangerous thing with the whole tree. I'm not saying don't write tests. Like, you should absolutely write tests. And if those are the best you can do because of what we mentioned before in terms of, code that's not already testable, is really hard to do this for. It is definitely like, it is something that you'll have to contend with. And so, like, just be aware of it, I think, is more my point than anything else. Yes, assert true.
Yeah, that'll do it. I mean, this just illustrates the point that the road to hell is paved with good intentions, right? That, it's always like, oh, we'll come back and fix this. But I wonder if, I do have a thought, on this bigger problem. Like, obviously, I guess when I'm trying to work in this kind of stuff, I'm either trying to change the test or change the code. I never try and change both things at the same time. Like, I'm going to change the code and then make sure the test fails. But maybe for this kind of code here, where we're talking about highly coupled, lots of mocking and this sort of stuff, I guess maybe one, I don't know what other people think about this, but I'm thinking that if you don't change the actual structure of the method you're calling, but you're only changing stuff that is involved in the setup, the arrange, act, assert kind of thing, right? If you're not changing the assert piece, but you're changing the arrange, does that, frequently I find with these kind of things, like if I'm thinking about Power Mockito, all of that stuff is being set up in the arrange part of it. And when I'm trying to refactor to get rid of those things to make the code better structured in terms of dependency injection or all those kind of things, I'm changing the code at the arrange portion of the test. So the assert is still going to be the same, I'm hoping, and give me that same warm fuzzy feeling that I haven't broken stuff. Does that chime with anyone else's experience?
It does.
Mhm.
I'm trying to think of like counter examples right now, but no, I think you're right. For it's probably the majority case. Yes, that's absolutely true. And in ideal world, everyone would write their tests in format that's easy to distinguish and easy to trust. However, I know a lot of times I don't. I'll confess. So like I mean, it's absolutely true, and like that is kind of the point. Like it's all in the what is the setup required for this, and like that's where all the smells are going to show themselves for the most part. Like so yes, I guess you should always be able to trust the asserts, but I don't know. It's
I mean, yeah, we can think of counterexamples, but I think all the counterexamples are really smells themselves, right? It's like if I had mocked something and then was spying to make sure it called some method that did a side effect, and that was important to the test passing, I mean, that's a smell right there, right? So I think it's going to have issues regardless. Yeah.
Yeah, I think for me, I usually treat tests as a form of documentation. So I don't find that I often delete tests. The only time that really happens is if the behavior is truly changing. So something that was valid, something that this, class or function or library did before, and now it's changing because of the new requirement. Sure, I'm going to delete that code, and then probably the tests that go along with it because the behaviors, not there. But this is where, to me, the interesting part of the end of chapter 4, the problem of over testing. Like, I don't think that's true. I wish that was our problem. I wish there was libraries and frameworks that were over tested, because I don't think that's true. And even if it was, so what? You have more tests. As long as they're quick, who cares? But yeah, I treat them as a form of documentation, not just for myself, future me working in this area again, but for anyone else reading it. I think it's important. As long as the tests, tell you something about how this thing is supposed to, work, even if it's saying it the same way 4 different ways, so be it. It'll help maybe the next person. Maybe it helps them understand or something clicks. But yeah, I don't see that as a problem. I wish it was.
So you bring up a good point there. And he did, like, to be fair, he did say that the issue of over testing is vanishingly rare, like meaning it's like
Right.
the extreme exception. So I personally painted it as like, oh, he contradicted, like, write a bunch of tests, don't write some tests, you're writing too many tests. Like, yeah, but totally valid there. But then the other point, so when he was talking about the idea that your your test should not be testing like the public API entirely. I think to your point, like that's where I tend to disagree with the notion like you shouldn't test how the code is used. Like to the whole documentation point, it's important, I think, even to the other point that he made about how there's like duplication in tests. And so he went through a whole thing about like shared fixtures and moving things around so that and I agree with that a lot of the time. However, sometimes I tend to try to err on the side of not using like the idea of like duplicated code inside tests. And the reason for that is I think when you're treating tests as documentation and you're looking at like an individual test method, if you have to then understand the structure of the test and like go look at, oh, what kind of setup is done before this, and depending on how long the test file is, versus being able to look at like one method that has your setup, your execution, and then your asserts all in one page that you can read and like cognitively understand quickly. Like I tend to err on it's okay to duplicate stuff in tests as long as it's not expensive. So like the whole moving things into set up like shared fixtures that are expensive, fine. But like when they're not, don't spend too much effort, I don't think, on like, oh, let's abstract this, how you create a new thing that we're testing. Let's move this somewhere else so it's really complicated, because you need to understand how to set everything up to be able to understand what the test is actually doing, I think. So like that's one thing that I found in this chapter that was kind of weird, was when he was harping so much on like this isn't a testing book. However, my opinions are, you should always do this. Is like, don't chase down like refactoring your tests in that respect, because you're just doing someone else a disservice later.
Always awkward when someone goes on a long tangent. It wasn't a tangent even. It was very focused.
Yep.
But then we just all sit there quietly. That's why I love that. Not just this room, but every room. Always. But I agree.
We're all
I
just
agree
like,
with you.
we're
100%.
just mentally digesting.
Let me just throw that comment that I agree.
There you go.
I'm waiting for Jeremy to come in and say, well, no, well, actually, you're wrong because these reasons.
We're all waiting for it.
Oh my God. Is that the reputation I have now already? Wow. Wow. No, I mean, it's a matter of style, right? And so much this comes down to taste. It's neither right or wrong. It's just what do you like to see in code? And I think if you can justify why you're making those decisions, that's all we can do, right? I mean, we can have conversations about that, but I mean, it's at the end of the day, a lot of the stuff that's what makes this an interesting job, right? If there's just one way of doing everything, it'd be like a factory.
Peers would do it themselves.
Yeah.
So. There is actually a right way, Jeremy, and it is, however, the person who merges your PRs, whatever they think is the right way, that is the right way to do whatever you're doing, right?
Now we're moving into culture problems now. It's another book as well.
Yes.
It's however many of your teammates you have to get to approve your PRs. That's the correct way.
Yeah.
Yeah.
It's the argument for small teams. There you go.
Yeah, there you go. Small teams with one person, you only have to appease, right? One style guide, one rule set. Yep, I like it. Cool. I think we're over time now, so it's a good discussion. Does anyone have any last comments or rants or tangents, as Jeremy Ward calls them?
More of a preview and a warning, I guess. So chapter 6 is a big one. So these two, and we didn't even discuss the very brief chapter 5, which was just an intro to chapter 6, really. But we read like 15, 17 pages last week. Now we're looking at 50 plus. It's like a third of like the last 5 weeks. So be prepared. Get ready. Is it going to be a double session? Extra long.
So I think just about that. So what we talked about is, instead of treating it as everyone read the entire chapter and like, let's point by point digest it, it was more of it would be advantageous, I think, if we kind of pick a couple of the refactorings out of the chapter that you like, or you want to not like, but like that you see a lot, or that you are interested in learning more about, and you want to read through them and like really digest a couple of them, so you're not having to read 60 pages and try to keep a catalog of, because the rest of the chapters in the book are more of a catalog for you to reference, more than they are like a book or a introduction to anything. So I think it would be a good idea. I'm not going to say you have to like sign up for any in particular, but we may play like the first one and see how that does. Just kind of go through and look at the refactorings that are in that chapter, and then pick out a couple of them that you want to explore and kind of explore those. And then we can use that as, everyone can go around and just kind of introduce what they learned, what they thought about, and we can ramble from there, if that works with everybody.
Maybe it will be interesting. I don't know if it's feasible, but it is like a shared problems book. Okay, you have this situation. What will be good, recipes to use, right?
Yeah, exactly. Yeah, and it's like, if you're able to do that, like that would be really cool too. Like, just, I picked this one, I found it, here's my strategy for it. Or even better, if you happen to find any of those this week while you're doing something, like, I did this week and it luckily was in chapter 6. So let's talk about what I did or didn't do, or where I got stuck, or which tests I didn't write, or which tests I deleted or didn't delete, depending on who you are. Yeah, I think that would be cool.
just the moment to remind everyone about their NDAs and job security and all that sort of
Oh
stuff.
yes. Don't bring stuff that's gonna get us in trouble, right? Like, or get you in trouble, worse. Like, yeah. Yes. Very good point. Thank you, Jeremy. All right. Thank you all for your time tonight. It's a good discussion. We'll see you next week.
See y'all.
Awesome. Thanks, guys.